Welcome to Landwards, the podcast for the land-based engineering community, brought to you by the Institution of Agricultural Engineers.
Hello and welcome to Landwards, the podcast of the Institution of Agricultural Engineers. I am your host, Andy Newbold, and I am joined today by Clive Blacker, who is Head of Business Development for Arable, for Map of Agriculture, and he's a commercial partner of the Hands-Free Farm project. Hello, Clive.
Hi, Andy. How are you doing?
I'm really well, thank you. Thank you very much for joining us today, Clive. How are you, Clive?
I'm very well, and I'm over the moon that this is a podcast and not a video. A wise chap once told me that I have the sort of face that's very good for radio, so this should fit really well.
We wouldn't like to comment on that, Clive. Anyway, moving swiftly on, tell us a little bit about your background.
So my background is I'm a Yorkshire lad, born and bred. Come from the Vale of York, and I was born into a family farming business with farmers and contractors in the Vale of York, and that's really how I got involved in the industry, being born into it. Educated in York, joined Young Farmers, went to Harper Adams to study. I'm sure you've got comments on that. That's where I had the pleasure of meeting you. And
studying was something I never shared with you, Clive. You attended, in my experience.
We had different interests.
Potentially.
Fluid dynamics, I think, was a very popular course. And anyway, so studied at Harper Adams, left Harper and joined the family farm and contracting business, and got quickly involved in the contracting work that we did. We were commercial contractors doing custom harvesting. We would contract farm for the farmers. Dad was very passionate about sugar beet, so we did an awful lot with sugar beet. There was about 1,000 hectares of sugar beet, 1,000 acres of sugar beet we'd plant. We were harvesting 600 hectares by the end of it as well, with a 6-row sugar beet harvester. And then York Sugar Beet Factory closed, so that all stopped. And at a similar sort of time, I'd been getting involved with precision farming, and as a result, sort of diversified out of the family farm after doing an Nuffield scholarship, looking at precision farming into what a lot of people know me for now as being somebody that's a bit of an anorak around precision farming and technology.
Yeah, I'm not going to argue with that, Clive. The standard question at this point is, why did you decide to become an agricultural engineer? But I have a suspicion you may not give me the answer I'm looking for here.
Well, I don't consider myself an agricultural engineer. One of the things that you learn as a farmer is that you've got to be a jack of all, and I would class myself with lots of different skills, and engineering is one that I had to learn and practice because I was so good at breaking, bending, and damaging things to keep the job on the road, so to speak. I learned all my welding and skills with metalwork from my inability to drive properly and poor visual accuracy. I wouldn't really class myself as an engineer. I'm self-taught in everything I've done. I didn't study engineering, and I hold engineers in huge regard because of their abilities and their skills. And for me, sometimes the option was always a bigger hammer to get something in a hole, rather than using the proper tools and effects that engineers would. And they're probably all despairing at the thought of that. So I really don't class myself as an engineer at all.
So would you describe your sort of ag engineering skill set as, in army terms, a bit of an infield commission, shall we say, in service?
Absolutely. Yeah, you've got to do what you've got to do to keep the job on the road. And that's really where our skills came from. We were never frightened to taking things to bits to see if we could mend it to get you going, rather than waiting for something if it didn't exist. And our sugar beet harvester was the classic example. I had no electronic skills until I had a sugar beet harvester, and then quickly had to learn what a multimeter was and how to beat wires through, because when stones go through wires or water in electronics, they don't mix so well. And that's really where I learned all my electronics knowledge, was from trial and error, so to speak.
And do you think your interest and your passion for sort of precision farming and the early stuff about auto steer and guidance was directly related to your lack of skill of driving in a straight line?
Absolutely. Anything that could do a job better than me, and it didn't have to be particularly good to be better than me, it meant that the job would get done properly and with a damn sight more accuracy. Part of the bit I hated most about spraying was when I drilled a field, because the tram lines were never in the right place. My mental capacity to concentrate on a job was always limited. So, any technology was always attractive to me that could do a job better than I could.
Presumably you could relate to Jeremy Clarkson with his tram lining incident and with his drilling.
Oh, very much so, yes. And yeah, I don't think I was ever quite as bad as that, but
it was his first time out in the field, to be fair.
There were times it could have been comparable, if it's fair to say, and there are several farmers in the local vicinity that I'm sure would back him up on that.
Yeah, no, fair enough. Just going back to doing HND and Ag at Harper, do you think at that point you had any kind of inkling as to where you were going?
No, I certainly didn't. When you're a young lad, agriculture's sort of it's something you've grown up with. It's something that I'd worked on the farm since a fairly young age, helping out at harvest and enjoyed that. It was just a sort of passage of life and transition, really. It wasn't. It was what I don't know whether it's what I was expected to do. Certainly, it was something I wanted to do, but it wasn't something I was always encouraged to do. There was given different options if I'd wanted to take them. But agriculture was just something that so once you've done it, it's always in your blood, so to speak.
Yeah. The genetic curse, Clive. The genetic
Absolutely.
curse.
Yeah.
So, following qualifications, do you want to sort of give us a bit of an insight into your journey, which got you to where you are now, with a bit more detail?
Yeah, so when we left Harper, those wonderful days, obviously you're then back into the reality of life and working on the farm, and I was given a lot of responsibility on the farm, certainly around spraying and fertilizer spreading. And at the time we had a very old trailed sprayer that shall remain nameless, but it was an absolute nightmare. It had breakbacks that would prefer to be backed and broken than they were to be working in the field, and it was a
pig
of a thing. That's the word. Pig of a thing to use. So it really didn't. Sorry, Andy.
It's all right. That's obviously the sprayer manufacturer coming to you on Skype
that's
to
right.
complain about not giving them a name check.
Yeah, so the spraying was always a bit of a nightmare, but I took a lot of interest in it and really enjoyed the spraying. Actually, I enjoyed activities that you were hanging about in fields. It was always far better to be spraying a field than it was power harrowing one, for example.
Yeah.
And you got to see every part of the farm. I really enjoyed that. And you learnt your farm inside out, and you learnt new farms and fields inside out as you sat on the sprayer, taking interest in what it's doing and why you're doing things. And that was really the sort of introduction I had into thinking about variability and understanding variability, because when you're out putting fertilizer on a field and you can see you've got, in the Vale of York, we have very variable soils. And when you've got variability in fields, you see that not everything's got the same problem. There's different weed spectrums, there's different nutrient spectrums that plants need, there's different nutrient problems that you've got to try and correct. And trying to treat a whole field when only part of it needed it never made sense to me. So the opportunity to then start using technology or ways of understanding where those boundaries may be and how you could target them better was always something that I thought was appealing. And I always remember my sort of first introduction to yield mapping, for example. We went on a BASF open day down at Yorkfleet at John Fenton's farm, and Dad thought I was absolutely blown away by it. I was blown away by this combine that had a link to a satellite in space, and Dad thought John Fenton was absolutely bonkers because he would wait till the satellites were passing so he could go and combine certain fields so he could gather the data, and he really valued the data as opposed to the mentality of a contractor. You've got to get on and at any cost and get the acres through the machine, and the thought of waiting for something just didn't appeal. But that really sparked my imagination to, well, if technology can help us do that, then that could help answer some of the challenges I've got with managing this sort of stuff. And that's really what really piqued and sparked my first interest in technology, and the wonderful stuff that AGCO were doing at the time. We quickly got involved with or trying to find technologies to help with that, and we quickly started looking at soil sampling and how to vary our P&K products. And we became contractors for SOYL, working with them, spreading P&K across Yorkshire. We spoke to IAgrE, and at the time they were developing their end sensor technology, and that was sort of new to the UK, and we got involved with that, and it was really that technology that really brought home the ability and capability of what technology could actually deliver. You know, the end sensor was a real revolutionary sort of, you know, leap for mankind in some respects to precision agriculture. The ability to put spectral machines on top of a cab and monitor the crop as you go through it to change the rate to the crop requirements in season made so much sense, because you have the opportunity to change it. Well, yield mapping is excellent, and it's a fundamental part of what we need. The ability to change a crop within a season, not just analyze it at the end of the season when you can't do anything, when it's in the shed. You know, the value isn't always as retrievable from that sort of technology. So the ability to work with that technology, you know, was really quite compelling to me, and really allowed us the opportunity to challenge our thinking, the way we did things. That's what got me into variable rate, and I was using all that technology as a farmer and operator at the time. In 2004, I applied to do a no-field farming scholarship because I was quite excited about where I could see, you know, these terms of auto steer being developed in different parts of the world, and that gave me the opportunity to travel across North America and through into Australia through the no-field network to really understand and see where technology is being used and deployed, and came back in some respects a little bit depressed, because we were probably, you know, the UK approach to growing crops and canopy management and real-time decisions and thresholds around IPM and other assets that we have here wasn't really being practiced abroad. You know, the Australians, they could be quite gung-ho about how they did things. Americans stuck all their nitrogen in the seed bed through anhydrous in autumn when it was frosty, and thinking, how can you make that investment and not know whether you're going to get the crop in the ground? You know, it just didn't make sense. But what we were doing, you know, there was a lot of opportunity with challenging things in real time. And on that basis, at the time, IAgrE had a big change round as well. They asked me if I would take on the responsibilities for looking after the end sensor for them. At the time, there was, I think, 16 in the UK. And since then, really, I set my own business up. I left the family farm at the same time the York sugar beet factory had closed. We'd sold the sugar beet harvester, and you know, setting up my own business, it made a lot of sense. I could do what I really enjoyed doing, working with technology and helping farmers utilize and adopt the technology to do a better job, and then also helping them with the solutions they needed to deliver that. So you could really see things through and have impact and change.
So there was almost an opportunity because of the journey you were on regarding the technology and the contracting, plus a contraction of the contracting because of the sugar beet factory. At which point you thought, right, I'll just step from one side of the fence to the other, but carry on doing what you were doing essentially.
Absolutely, and you know, working in family businesses isn't always as straightforward as people think. There were certain relationship issues I had with my dad at the time. You know, working with your parents and working the hours that you work on farms. You know, it was probably an easier way out, to be quite honest, to go and do my own thing.
And so let's fast forward. What about now? Tell us about your day job now. What do you do?
So the day job now, I could see the challenge that I had with the business precision decisions, and the way that technology was going was very much more around data. The big challenge I still face with helping farmers with precision farming is really interpreting and understanding that data, and having the software capabilities or tools that allows a farmer to simply be able to interrogate data and make decisions on it. And no matter what form of engineering or technology you employ on farm today, our ability to capture data in high resolution and different forms of data is just exponential. You know, it's horrendous the amount of data that's available to us that we could potentially use if we had the capabilities. And while I realized that precision decisions had to move in that way, we didn't have all the skill sets. We were more of a sort of practical based company. It made a perfect sense to me when I had the opportunity to join in with another business that was a data business looking for on-farm presence and precision farming support, to merge the two together. So I merged precision decisions with Map of Agriculture in 2018. So we've been together nearly 3 years now. And you know, the concept being that we can now work with some serious data engineers with are smarter in sort of data engineering rather than machine engineering to really allow us to try and be disruptive with these different sources of information and support farmers in different ways with the information that machines are gathering as the pace of engineering's changed with the technologies that are collecting that data. So the day job today is probably more sat around a computer, designing solutions and concepts to try and work with farmers to deliver information back to them around how they can improve or utilize the data more effectively to improve their day jobs.
Yeah, so decision support.
Absolutely. I mean, an example of that this year, for example, we've been working very closely with the technology that we used with IAgrE in the early days with the nitrogen management to build new metrics around nitrogen use efficiency. You know, it staggered me sort of 4 or 5 years ago at home that we apply nitrogen as our biggest single input to a crop, but I had no idea how efficiently I used it. And it's quite frightening when, you know, the mapping we did for Kellogg's this year, we identified use efficiency varying on farm between 45% accuracy or efficiency up to over 120% accuracy. You know, so people putting and taking off more nitrogen they're applying, where others are leaving over half of what they've applied somewhere in the environment.
Yeah,
and then
not
designing
necessarily for the next crop either.
That's right. And so we've been, you know, designing solutions and tools and methodologies to try and support those farmers to improve that decision-making process.
I think it's fair comment. Now, so you do also sort of live another professional life, Clive, don't you, as a trustee of the Douglas Bomford Trust? Do you want to tell us about the Douglas Bomford Trust?
Yes, I joined the Douglas Bomford Trust now a couple of years ago as a trustee. A very great privilege to be invited and
especially as you're not an agricultural engineer.
Absolutely.
Yeah. Application forms are available.
Absolutely. Well, I think yes. Should I say at this point, I agree there, Andy. I think that's right.
Yeah, moving on, Clive.
Sorry. So the trust. I mean, the trust is quite a fabulous little trust. Its capabilities to make a difference are quite, particularly to engineering, are really important. You know, the main objective of the trust is to advance knowledge, understanding, practice, and competence within agricultural engineering, to help people understand the technology to achieve sustainable agricultural, food production, biological systems that benefit the mankind and the environment. And that again, all that is really passionate about what I do on the farm or have done on the farm and where I use precision farming. But from an engineering perspective, engineering I see as being probably one of the biggest blockers that we've got, as well as the biggest enabler capability that we've got as well going forward. So the trust role is quite fundamental in the background, supporting students to be members of IAgrE, for example, paying their fees, and to also allowing studentships and research to continue with support of people from industry that can offer some opportunity to mentor and guide people in the right direction, while raising the profile of agricultural engineering, which is often overlooked and far too regularly.
What's the history of the Douglas Bomford Trust?
That's a really good question. No, it was set up. It's a family trust. It was some money that was left over from Douglas Bomford and what he was achieved, the wonderful things he's achieved in his lifetime. That's been very wisely invested to with the ambition, as I said, to support agricultural engineering going forward.
Good answer, Clive, particularly because I threw that one in and you weren't prepared. So I'm very impressed with that. Thank you. So looking forward, where do you see, if we're looking around and take on board the context of within agriculture, where do you see agricultural engineering as a discipline going? Where do you see it going?
Oh, well, agricultural engineering is still fundamental. We're always going to need some form of engineering to take things forward. Quite how that engineering manifests itself and progresses, I don't know. I often see the engineering being probably a tool to enable technology to some extent, as a system to enable that technology to do its job in the field and to capture and respond to technology requirements. It really is a fundamental tool that we need, and it's probably got to now go through probably one of its biggest changes and transitions I think that can happen. There's so much opportunity in the agricultural engineering aspects that I really think are really important to the future.
Now is a good time to be an agricultural engineer. Have I mentioned joining the professional body for agricultural engineers at this point, Clive, as well?
You have, and certainly
fine.
Anybody that's considering it, I think they should seriously look at it, particularly those with a qualification in engineering.
There's always a way in wherever you are, Clive. What about issues then? What do you think of the issues facing agricultural engineering?
It's easy for you to say.
Yeah, well.
So the issues, I see ourselves as being at a real crossroads at the moment with where we're heading with data and technology compared to the sort of science and scale of electronics and where we're going to end up as an industry. And with engineering to some extent being a bit of a forgotten science that enables all of this to happen. I think the successes that the engineering industry has made in terms of improving the size and scale of machines and the phenomenal outputs that we can gain are just absolutely tremendous. I'm in awe of our combine every time I see it operating. The capability for one man to be able to go out and cut nearly 100 acres or more in a day, when we used to bugger about with two little combines and nearly do half of that in the space of 20 years is quite phenomenal. But the scale also at times becomes the Achilles heel. It's allowed a farmer to save his biggest cost, which is labour, and reduce that, although machinery costs are certainly increasing. But the scale of what's happening is meaning that we're losing, to some extent, visibility and precision. And the bee in my bonnet I've often had about the scale is that, to use an analogy of the combines again, while I can achieve twice as much or three times as much in a day with the same man on a combine today as I could in 1998 when we first started yield mapping, I actually get 60% less yield data. So if I'm wanting to farm better and do a better job of farming and understand the drivers to crop production and the variability of those crops and how I could improve that, and particularly as we look at more environmental challenges that we're going to be faced with going forward, then the quality of the data that comes off these machines needs to improve. And I think that's where the dilemma is for me, is what's the optimum scale and the optimum resolution we should be doing things at that really have the impact that the farmer can benefit from on farm to make him more money to buy these machines.
Because a wider machine just gives you a muckier trail of data, which was a bit wider.
That's right. And, it's the same for the application technology. So, when we first started spraying with that horrible spray that won't be named, at 12 meters, we're now 24 meters, 36 meters. So when I can change the rate across a boom at 12 meters, I was doing it 3 times better, essentially, than I am today at 24 or 36 meters.
Yeah.
So, that technology is changing, don't get me wrong. The limitation still comes back to how we qualify the benefits of that through yield mapping in higher resolution and different challenges there. But as we think, you and I had the opportunity to trend groundswell a couple of weeks ago. And if you think about where groundswell and regenerative agriculture could well be looking in terms of the opportunities and what they're talking about with split cropping, intercropping and different cropping rotations, technologies to drill into cover crops, technologies to harvest 2 crops together, technologies to be able to manage and manipulate those are going to be quite important going forward to allow us the ability to really look after the environment and our soils and allow us the opportunity to have more profitability.
Yeah.
And that was something that did strike me, actually. I did see a fantastic use of technology in auto steer and biological engineering through genetically modified crops in America on my Nuffield study. There was a problem with nitrogen in the watercourses in Lincoln, Nebraska. The over-application of nitrogen was causing huge problems. There was high nitrates in water. Blue baby syndrome was very common and related back to the nitrates. So with auto steer and with other technologies, it was really hard to. It really opened up an opportunity for us to think about how that could be used. So what they were doing was establishing winter wheat with no nitrogen, planting 2 rows of winter wheat, leaving the 3rd row. And they could achieve that with auto steer very simply. In the 3rd row in spring, into that crop of growing winter wheat, they were then planting the soya. The soya would then grow, and as the soya got as the wheat got to maturity, they would come in with combine harvesters that could, again, precisely travel up the wheat rows, not damaging the soya, harvest the wheat heads off above the soya, and at the same time then allow the soil then to grow through, and essentially harvest 2 crops in one, treating them all with GMO crops with Roundup meant that they could keep very good weed control. There weren't the limitations. So essentially those farmers were achieving the productivity of sort of 1 3/4 crops in the same season as they would historically have only had 1 crop, but equally growing a crop a week without nitrogen, reducing the problems with nitrates. Yeah. So real fascination use of engineering and technology combined to really improve the farmers' welfare and the welfare of the populations and the environment.
So given the excitement you hold for this, what advice would you offer to anyone considering heading into ag engineer as a career, heading into agricultural engineering as a career?
Don't hesitate. I mean, agriculture is the most exciting industry that you could work with, and agricultural engineering underpins that. And the opportunity for change and excitement in that sector now is probably at its greatest with the onset of drones, of robots, of newer technologies that we're looking at targeting things in different ways. It really is an exciting and multifaceted, skilled opportunity for people to work in as a career. And there's nothing more fulfilling than working in agriculture. I mean, how many people are so relieved they're working in our industry after what we've just seen with COVID,
that's very true,
and everything else.
We've all still got jobs. We can all still get out there and be outstanding in our fields every day, can't we?
We certainly can. It's a very great industry to be part of.
Well, on that fine note, I think we will draw this podcast to a close. Clive, that has been a fascinating insight into your professional life and the journey thus far as well, which I'm sure is not over yet. So, Clive Blacker, thank you very much for your time today.
Been a real pleasure. Thank you.
Thank you, Clive. We'll be back for another podcast shortly. Thank you. Over and out.
For more information, visit www.IAgrE.org. You have been listening to Landwards, the podcast for the land-based engineering community, brought to you by the Institution of Agricultural Engineers.